This month's Storm of the Month presentation is going to be over the KDP detection for microburst. If you all can recall, I did a really uh, quick and brief presentation over this exact same topic for the spring severe weather seminar, and I am just going to be going over a few case examples of a few instances where it has actually worked decently well for myself while working radar. So, just a quick review from the Spring Severe Seminar. Around 99% of downbursts were associated with a KDP core, and that is from a study from a Custer et al. 2021. Strong downbursts typically had higher values of KDP near the environmental melting layer, and downbursts occurred 10 to 30 minutes after a developing KDP core. This slide from the Custer et al. Paper, this is just a pretty general idea of what to look for when working radar. The box in the upper left, that shows the developing KDP core and how it just continuously strengthens all the way through box D, which is roughly 10 minutes later. That is a fully mature KDP core. So pretty much in between box D and box H, which can be as long as 30 minutes, as I said on the previous slide. That is the main window for when a potential downburst or microburst could occur. The first case that we are going to look over from this past summer. This happened on June 20th of 2022, and this was up in Decatur and Red Willow counties. The image on the left, it shows that there was no effective wind shear or anything at all within the environment in our area. And the image on the right shows that there was roughly 1,300 to 1,600 decape available. So one of the hypotheses that I had is that perhaps when there is less than 25 to 30 knots of effective bolt shear present, and then that will create more of a downbursty environment. And then obviously if you have over 1,300 joules of decape, then that just shows that the atmosphere is pretty much essentially primed for a fairly strong wind gust to occur. So the first slide here that I'm going to show you, this is at 2113Z. The area that you are going to be looking at is going to be on that cell just to the northeast of Oberlin there. I included the lightning data as well, which is the very bottom image, and make note of how there is no lightning present there. Moving on to 2117Z, you can see that there was a little bit of a uptick in lightning associated with the storm. That is reflected by the image on the very bottom of the screen there. And then you can see a KDP core beginning to develop as well. And then roughly 3 minutes after this radar grab, there was a 65 mile per hour wind gust that was reported by the Kansas Mesonet site. So, after seeing this occurrence and everything, that led me to another hypothesis as well. If there is a associated lightning jump with a specific thunderstorm, if that would correlate as well with the KEDP core. And I should have included the exact site location for the Kansas Mesonet site up there, but it is just roughly a little bit, or it is just roughly a little to the southwest of the current storm that we are focusing on. This image is right after the 65 mile an hour wind gust. As you can see, there is a pretty well defined increase in lightning as well, which is indicated by the blue circle. There's a pronounced KDP core right there as well, looking at the image on the right. And then I will have you then address your attention to the next cell of interest. That's going to be developing in southern Red Willow County, and that is going to be highlighted by the area in red, where you can see that there is a little bit of lightning beginning to occur with that specific cell. At 2129Z, you can see that the cell that was down in Decatur County, it just overall does not look as impressive at all on a radar, and the overall lightning trend has decreased as well. Looking up at the main storm of interest now in southern Red Willow County, that is highlighted by the red circle, you can see that there was a significant jump in lightning with that cell, and then you can see perhaps a little bit of a KDP core beginning to develop to the north of Danbury. Moving on now to 2134Z, you can see that there was a significant uptick in lightning with the storm of interest as well. There's a very pronounced KDP core. And then roughly 5 to 6 minutes after this radar grab, we had a estimated 70 mile per hour winds reported by Bartley. There was also a severe thunderstorm warning put out for this specific cell of interest, as it was showing very similar characteristics to the to the cell that produced the 65 mile an hour winds down in Decatur County, roughly a half hour before this storm. This was the image right after the estimated 70 mile an hour winds were reported. You can notice that the KDP core has completely dissipated as well. So that would go along with the Custer et al. Paper that with a dissipating KDP core is when the downburst will occur. And then at 2154Z, as you can see, all of the storms and everything, they have just completely dissipated. Our next case is going to be on July 3rd, and this was in Sherman County. And again, looking at the environment, we had no wind shear again whatsoever, and the D Cape, that was again 1200 plus joules being present pretty much over our entire forecast area. So 2338Z, you can see in my blue circle that there was some lightning beginning to show up with this specific cell that was to the southwest of Goodland. 2344, a very intense KDP core. The overall density of the lightning again picked up. And then there was a 59 mile per hour, 2 meter wind gust reported by the Kansas Mesonet site, which is directly in the heart of that KDP core. And we got reports of multiple power poles down at 2345Z, which is roughly a minute after this radar image. And then at 2346Z, you can see that the KDP core is still present, and the lightning has ticked down just a hair. And 2352Z, the lightning has again ticked down a little bit as well. So the one thing that I would really want to look into a little bit more is you are probably noticing that the KDP core is still fairly high. I'm wondering that perhaps just due to the close proximity to the radar, if that was playing a major influencing role in that as well. So perhaps the overall density of the lightning may perhaps be another way that you can get ahead of a potential downburst occurring. Another case that we had was on July the 8th, and this one was in Greeley County. You can see on the effective bulk shear that there was a 30 to 40 knots of wind shear present, mainly to the north of I-70. But in Greeley County itself, at least according to the SVC Meso analysis, there was 30 knots of wind shear present, and the decay, as pretty much normal out here during the summertime, is again well above 1300. So the storm of interest is going to be the most southern one. And my apologies for not trying to increase the size of the lightning on the specific cell. But if you look closely enough, you can see that there are some like little tiny blue specks and everything going on within that cell. 5 minutes later, you can see that the lightning within that cell really ticked up, and there is a fairly intense KDP core occurring as well. Another 5 minutes later, KDP core is still there, lightning continues to be strong. And then moving on to Tuesday, you can see that the KDP core has significantly weakened, and the overall lightning has decreased as well. In between 150Z, which was the previous slide, and this slide, there was a weather underground site roughly 8 miles to the east of Tribune, and that registered a 60 mile an hour wind gust as well. So that is again another good example of the Custer et al. Paper working to help us gain lead time with any potential downbursts occurring. In summary, a rapid uptick in cloud lightning, along with a strong KDP core, those are the main keys to being able to pick out a specific cell when trying to get an idea of what may or may not produce a downburst or a microburst. I'm still working on trying to see if there is maybe a lightning threshold that could help with any potential over warning or any other messaging issues on something that may produce a downburst or a microburst. In all the cases I've looked at so far, it looks like that there needs to be at least 50 in-cloud lightning strikes present. But again, I would obviously need to look at a lot more cases and scenarios. For the environment, it appears that there needs to be less than 25 knots of effective bull shear present. All the cases I showed you today, which is why I included just a really brief overview of like what the environment looked at. All these cases had less than 25 knots. And then looking back at the last September Burlington 110 mile per hour microburst that occurred, there was indeed less than 25 knots of wind shear present as well with that specific cell and environment. The decay needs to be fairly high, which isn't too hard to happen out here in the middle of the summertime. In all the cases I've looked at so far, there had been at least 1,200 joules per kilogram present. So the main thing to perhaps take away from this entire presentation is that the environment may be the key, as it seems that not all high KDP cores produce downbursts. Then when I say that not all high KDP cores can produce downbursts, KDP, that is another way to identify which portion of the cell has very heavy rainfall or just lots of hail and everything present. So if there is greater than 30 knots of wind shear, for example, then perhaps that KDP core that could just be showing just very heavy rainfall or just a lot of hail. But that is just something that will need to be looked at along with all of the other dual pole products that we have. And then these these can be kind of considered as confidence nudgers as well. So it is obviously not if you see a high KDP core and a rapid uptick in the lightning in an environment that is very supportive, that still doesn't mean that a downburst could occur. I say this as a confidence nudger. You could kind of compare it to a QLCS tornado event. Is if you just see like multiple different check boxes or whatever you want to call them that you can check off, that it will increase your confidence in issuing a warning or not issuing a warning. So again, I'm just kind of considering these to be a confidence nudger. And then looking at future thoughts and ideas for the environment, I'm curious to see if the height of the environment freezing layer can play a role to see if low or mid-level lapse rates, whether they're high or low or in the middle, can play a role in if a downburst can occur. And also the speed of the 850 or 700 millibar winds can play a role as well. And then some additional thoughts that I had is perhaps um, playing with a different VCP, let, let- playing with different VCPs in the radar as well, because something interesting that I have noticed is that I hadn't been able to pick up on a clear velocity signature as well with any of these cases. So perhaps the downburst is happening in between all of the radar scans. So there are obviously quite a few unknowns and everything that I have still. So as I said, you can pretty much take all of these as a confidence nudger if you are working a if you're working a radar shift. So I thank you for your time, for listening to everything, and if you have any questions over any of this material, you can feel free to ask me at any time. I'm always willing to help out, and I'm always willing to listen to like any potential suggestions as well. Thank you.